Okay, welcome back. A couple things before we end here, and that's just to realize, just like with the exponential function, the parent graph can have any base. So we've been mostly talking about log base 10 of x, and in the calculator, it only can do the log base 10 of x or the log base e, which we also call the natural log of x, the ln of x. And some of the calculators can do it differently by changing the base, but most of them you have to use a change the base formula. So I'm going to be showing you that next so you can check. But any base can be used for a log for the parent graph. And also you still have the a, h, and k here. All of these can be transformed, our a, our h, and our k. So remember, from the beginning of this page, the beginning of the notes, we had these equations, and this has no transformations. This is a parent graph of log base 10 of x. Here, the transformation, we have a k. So this is plus 5. So our k, remember, moves it up and down and in the same direction. So it's going to move it up 5, which makes sense when you look at the graph now. It moved this function up 5. Our second one, for f here, it has an h. And remember, our h is, the equation is a minus. So here it's actually moving it in the -2 direction, so left 2. And if you look at our f function here, it does move it left. So this is the same graph. D here is the same as f, except for everything was moved to the left 2 spots. Okay, so we'll be practicing more of these transformations in class and in a minute here on the notes. But before we do that, I want you to know how to put this in the calculator so you can check when you switch your inverse points. So I want you to write in your summary. So on the bottom of your page here, I want you to answer question number 1. How do you input a log equation into the calculator if the base is not 10? And I should have also wrote not e. So let's add that. Okay. And we're going to be doing that. I'm answering this question number 1 here using this change of base formula. This equation you want to write down, and it's the log base b of any item. You can use the change of base to solve in other items, but here we're going to be using for graphing. And what you do is you change it to one of the common logs. So the common is 10, log base 10 is a common log, or log base e, which is also called the ln. So either one you can change it to. The calculator will calculate it for you. So it depends on what you want to do. But it's going to be the of part over the base. So remember how we say this, log base b of m, and you can set that in the calculator as log 10 of m divided by log 10 of b. Okay, so let's try that in our calculator. Pull your calculator up and notice how I changed my log base 2. Let's write that here. The one we just graphed, log base 2 of x, and I'm going to put in the calculator using this formula, log base 10 of x. We don't have to write the 10. The calculator just assumes that, and that's what it's going to use for the common log, over log base 2. Okay, so we're just using this one. It's the big number here, over the base. So log of the big number over the log of the base. So you put that in the calculator that way, log of x divided by log of 2. And you can see we got the same graph that we came up with using our knowledge of inverse. our table here, you can use that also to graph. So I want you to know both methods so you can make sure the calculator is making sense to you, and you can use the calculator to check. Alright, the last thing I want you to try is to graph these the same base from original problem here, or 2 of the x. And I want you to pause for a second and figure out what transformations are made here with our h of x and our k of x. So pause and come back. So our transformations were right 1 and left 2. So you can use the parent graph and just move everything to the right one for number 1. And our parent graph of the log, you're going to move that left 2. So go ahead and graph that on your page. I know they're small on there, but go ahead and give those a try. Okay, so you should have these 2 as your final graphs. Last thing I want you to do is to go ahead and answer question number 2. What references can you use to help your graph an exponential function? And what about for the logarithmic function? Go ahead and try to write that down and bring it back. Okay, so all our parent graphs, exponential graphs, have a horizontal asymptote of y equals 0. So that's a reference that you can use and move that with the transformations. And secondly, the y-intercept of all our parent graphs is 0, 1. Also, you can always use that table to help you. For logarithmic, the parent graphs have a vertical asymptote of x equals 0, and the parent graphs have an x-intercept of 1, 0. So you can use that to help you move around to get your graph correctly, and also the other points on the graph. Okay? Have a great night. I'll see you in class.